Section 9.3 Systems of nonlinear equations in two variables. A system of nonlinear equations is a system of two or more equations in two or more variables containing at least one equation that is not linear. An equation that's not linear can be a quadratic equation, circle, ellipse, or exponential. So as long as one of the equations is not linear, then we have the system of nonlinear equations. For example, if we have a system of a line and a parabola, this is a system of nonlinear equations, and we have three types of solutions. We can have no solution if the line and the parabola do not intersect each other. We can have one solution if the line and the parabola intersect each other at one point. Or we can have two solutions when the line and the parabola intersect each other at two different points. If we have a system of a linear equation and a circle, then we do have three types of solutions as well. Either no solution, one solution, or two solutions. If we have a system of two circles or one circle and one ellipse, we can have no solution, one solution, two solutions, three solutions, or four solutions. Example 1. Solve the system. I have two different equations. The first one is x minus y equals negative 1. The second one is y equals x squared plus 1. The first equation is a linear equation, and the second equation is a quadratic equation. To solve the system, I can either use the substitution method or the addition method. In this case, I will use the addition method. When I use the addition method, I want to add the two equations so that I can eliminate one of the variables. I can either choose to eliminate y or x. In this case, I will choose to eliminate y because negative y plus y will be cancel each other out. I cannot eliminate x because x and x squared are not like terms. So I am going to add the two equations. When I add these two equations, negative y plus y is 0. Negative 1 plus 1 is also 0. I have x equals x squared. This is a quadratic equation and one unknown. In order to solve for this equation, I need to bring everything to one side. I will bring this x to the right side. So I am going to subtract x from both sides. And I have 0 equals x squared minus x. To solve for this equation, I am going to factor the x out. So I have 0 equals x times x minus 1. So I have either x is equal to 0 or x minus 1 is equal to 0. So I have two values of x. X can be equal to 0 or x can be equal to 1. Next, I need to find y. In order to find y, I need to use one of these two equations. It doesn't matter which one, just pick one. And then I will substitute the value of x in here in order to solve for y. I am going to use the second equation, y equals x squared plus 1. I am going to substitute x equal to 0 into the equation y equals x squared plus 1. And I have y equals 0 squared plus 1, which is 1. So my first solution in an order pair format is x comma y. My x is 0, my y is 1. So my solution is 0, 1. This is the first solution because I use x equal to 0 to find the corresponding y equals to 1. Now I need to use x equal to 1 to find its corresponding y. I will substitute x equals 1 into the equation y equals x squared plus 1. And I have y equals 1 squared plus 1, which is 2. And my solution 2 is when x equals 1 and y equals 2. So I have two solutions. The first one is 0, 1, and the second one is 1, 2. You can also verify your solutions by looking at the graph. I am on Desmo.com right now, and if I click on Graphing Calculator, I'll be able to graph my two equations on here. So first, let's graph the equation x minus y equals negative 1. And then let's graph the parabola y equals x squared plus 1. So as you can see, my parabola is intersecting my line at two different points. So these two intersections are my solutions. The first one is 0, 1, and the second one is 1, 2. Example 2. Find the intersection of the given circle and the given line by substitution. I have two equations, x squared plus y squared equals 5, and y equals 3x minus 5. The first equation is a circle, and the second equation is a line. In this question, they asked me to use the substitution method to solve for the system. But even if they don't ask me to use this method, I will not be able to use the addition method either, because y and y squared are not like terms. X squared and 3x squared are not like terms. I will not be able to get rid of one of the variables by the addition method. The first step, I am going to substitute y equals 3x minus 5 into this equation. So y is equal to 3x minus 5. And I will substitute that into this equation. So I have x squared plus 3x minus 5 squared equals 5. I am going to multiply 3x minus 5 squared out. 3x minus 5 squared is equivalent to 3x minus 5 times 3x minus 5. I will distribute this out. I have 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. Negative 5 times negative 5 is plus 25. So I have 9x squared minus 15x plus 25. And I take negative 15x minus 15x. I have 9x squared minus 30x plus 25. And I will replace that with 3x minus 5 squared. I will combine x squared and 9x squared to make it 10x squared. This is a quadratic equation. In order to solve for a quadratic equation, I need to bring everything to one side. So I'm going to bring 5 to the left side by subtract 5 from both sides. And I have 10x squared minus 30x plus 20 equals 0. When you are solving for a quadratic equation, you can either factor or use the quadratic formula. That is totally up to you. From here, if my equation is factorable, I will try to factor it. So if I look at 10x squared minus 30x plus 20, I know that they have 10 is a common factor, so I'm going to factor 10 out. And I have 10 times x squared minus 3x plus 2. X squared minus 3x plus 2 is factored to x minus 1 times x minus 2. So I have either x minus 1 is equal to 0 or x minus 2 is equal to 0. So I can have x is equal to 1 or x is equal to 2. So I found x. X can be 1 or x can also be 2. Next, I need to find y. So I go back up here and choose one of these two equations. It doesn't matter which one. However, I am going to choose this one. And I will substitute my x in here to solve for y. I am going to substitute x equals 1 into the equation y equals 3x minus 5. And I have y equals 3 times 1 minus 5. 3 times 1 is 3, minus 5 is negative 2. So my first solution is x comma y. My x is 1 and my y is negative 2. Next, I need to substitute x equals 2 into the equation y equals 3x minus 5 to find my second solution. And I have y equals 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. So y is equal to 1. And my second solution is x comma y. X is 2, y is 1. So I have two solutions. The first one is 1, negative 2. And the second one is 2, 1. Now, let's verify the solutions by looking at the graph. So first, let's graph x squared plus y squared equals 5. The graph of x squared plus y squared equals 5 is a circle. Next, let's graph the line y equals 3x minus 5. So this is the line y equals 3x minus 5. As you can see, the circle and the line are intersecting each other at 2 points. So this point is the point 1, negative 2. And this point is the point 2, 1. And these two intersections are my solutions. Example 3. Solve the system of nonlinear equations. I have the system of two equations. The first one is x squared plus y squared equals 26. The second one is 3x squared plus 25y squared equals 100. The first equation is a circle, and the second equation is an ellipse. To solve for this system, it will be easier if we use the addition method, because all of our x and y in the two equations are raising to the square power, and that makes it harder for us to solve for either x or y. So it will be easier for us to eliminate x squared or y squared. In this case, I will try to eliminate x squared. The coefficient here is 1, and this coefficient is 3. In order to use the addition method, I want the coefficients to be opposite. So this is 3. I want this to be negative 3. I am going to multiply both sides of this equation by negative 3. So I have negative 3x squared minus 3y squared equals negative 78. My second equation stays the same. 3x squared plus 25y squared equals 100. And I am going to add the two equations. Negative 3x squared plus 3x squared is 0. Negative 3y squared plus 25y squared is 22y squared. Negative 78 plus 100 is 22. To solve for y squared, I divide both sides by 22. Y squared equals 1. To solve for y, I will take square root on both sides. And remember, when you take square root, there's always plus or minus. I have y equals plus or minus 1. What does that mean? It means that y can be either 1 or y can also be negative 1. So I found my y. It can be 1 or negative 1. Next, I need to find my x. So I have to use either one of these two equations in order to find x. It doesn't matter which one that you're using. I am going to use the first one, and I will substitute y in to find x. I have two different y's. So first, I will need to use y equals 1 and substitute that into this equation in order to solve for x. So I'll take 1 and substitute that into y. I have x squared plus y squared equals 26, and y is substituted with 1. So I have x squared plus 1 squared equals 26. 1 squared is 1. So I have x squared plus 1 equals 26. In order to solve for x squared, I will subtract 1 from both sides. The 1 gets cancelled out. I have x squared equals 25. And to solve for x, I'll take square root on both sides. And don't forget the plus or minus. So x is plus or minus 5. What does that mean? It means that x can be 5 or x can also be negative 5. So when y is equal to 1, x can be 5 or negative 5. That means for y is equal to 1, I will get two order pairs. The first one is 5, 1, and the second one is negative 5, 1. So when y is equal to 1, I have two solutions. Now I need to substitute y is equal to negative 1 in here to find my other solutions. So I take negative 1 and substitute into y. So I have x squared plus negative 1 squared equals 26. Negative 1 squared is 1. So I have x squared plus 1 equals 26. And then I subtract 1 from both sides. And I have x squared equals 25. To find x, I'll take square root on both sides. And don't forget the plus or minus. So x is plus or minus 5. So x can be 5, and x can also be negative 5. So when x equals negative 1, I have two order pairs. It can be 5, negative 1, or negative 5, negative 1. So for this system, I have four different solutions. They are 5, 1, negative 5, 1, 5, negative 1, negative 5, negative 1. Let's also verify this example by using the graph. So first, let's graph the circle x squared plus y squared equals 26. Next, let's graph the ellipse. 3x squared plus 25y squared equals 100. My circle and my ellipse are intersecting each other at 4 different points. 1, 2, 3, 4. This point is the point 5, 1. This is 5, negative 1. This is negative 5, negative 1. And this is negative 5, 1. And these 4 points are my solutions.